Between you pressing enter and seeing a single pixel, your laptop already talked to 4 different computers you have never heard of. None of them actually serve the website. They just tell your browser where on earth to find it. So what actually happens in that half second? Let's trace every hop, every handshake, every millisecond. First stop, DNS. Your browser asks a resolver, usually your ISP or Google's 8888 for an address. That resolver doesn't know either. It asks a root server, then a domain server, then finally the authoritative one. This chain can take anywhere from 1 millisecond, if cached, to over 100 milliseconds if it's cold. Chrome caches that answer for about 60 seconds. Your phone caches it too. Redundancy everywhere, all the time. Now your browser finally has an IP address. Time to open a connection. That's the TCP handshake. 3 packets, 1 round trip. SYN, ACK, AK, K. 1981 gave us this dance, and we still do it. If the site uses HTTPS, and it should, add a TLS handshake right on top of that. Before 2018, that cost 2 extra round trips. TLS version 1.3 cut it down to 1. So before a single byte of your actual page arrives, you've already crossed the internet 2 or 3 times. Here's the trick big sites use to cheat physics. They never let your request travel very far at all. Cloudflare alone runs edge servers in over 300 cities. Your request probably never leaves your own country. That's why a site loads equally fast in Tokyo and in Toronto, even though the origin server sits in Virginia. Connection finally open, your browser sends the real request. Get, a path, and a pile of headers. Cookies, user agent, accepted languages, cache headers. Sometimes the request is heavier than the response it gets back. On the other end, a server wakes up. Maybe it's Nginx, maybe Node, maybe a Lambda that didn't exist 5 seconds ago. If the page is dynamic, it might hit a database. One slow query can eat more time than everything before it combined. This is why engineers obsess over an unglamorous metric called time to first byte. Slower response times measurably drop conversion rates, according to research Google published comparing load speed against checkout completion. Bytes finally start arriving. The browser doesn't wait for the whole file. It starts parsing the moment HTML lands. It builds the DOM, a tree of every tag, and the instant it spots a style sheet, fires off another request. Here's the trap. CSS is render blocking. Nothing gets painted until every style sheet finishes downloading and parsing. JavaScript is worse. A plain script tag freezes parsing entirely until that file downloads and finishes running. Once HTML and CSS are both ready, the browser merges them into a render tree, then calculates size and position for every box. Only after that layout pass does the browser paint. Pixels fill in, colors apply, and something finally appears. That first pixel usually isn't your logo or your headline. It's the background color, painted before a single letter exists. Google calls that moment first contentful paint. On an average site in 2024, it lands around 1.8 seconds in. So the gap between typing a URL and seeing a pixel isn't empty. It's 4 networks, 2 handshakes, 1 database, racing to paint first.